So in the last few videos, we've talked a bit about what units are, how to convert them, and a little bit about how to use them. This video, I specifically want to look at how we figure out whether or not the units in an equation make sense. So let's take a straightforward equation to start with. F, which is force, is equal to mass times acceleration. So I'm always going to give you an equation that I want you to test whether or not the units make sense in. Now, the next thing we're going to do is look at the units of each individual value, each property, inside this equation. So we put them inside square brackets, units of force, and the square brackets, remember, are read as the units of force are what? Well, the units of force are newtons, but newtons can be simplified to kilograms times meters over seconds squared. Now, this is the SI system. If you want to do more generalized units and say just in general what property it is, then you're going to have, it's going to be mass times length divided by the square of time. The other properties in this equation, the units of mass are kilograms, or more generally mass, and the units of acceleration are meters per second squared, or more generally length over time squared. So those are our units. Now what we have to do is figure out whether every term in this equation makes sense. So recall that a term is anything separated by a plus or minus sign. If you don't see any, well, this is a term and that's a term. So looking at the terms, we already done what the units of F are. Kilograms, meters over second squared. Our second term is mass times acceleration. So we have to find the units of mass times acceleration. Well, the units of mass are kilograms, and it's being multiplied by the units of acceleration, which are meters per second squared. And this certainly matches this, which means we are all set. And if you need to see it out, well, we say, kilograms times meters over second squared. This is only multiplying the numerator, so we have kilograms meters over second squared. And if you want to use the more general units, then we have mass times length over time squared, which resolves to mass times length over time squared. And you can see that everything, both terms are the same, have the same units, which means you're able to do things with them, and it means that the units in the equation do make sense. Let's look at another equation. This equation is one of the equations of motion, one of the kinematic equations that we're going to be doing a lot with. So this equation I'm going to write VF, which stands for the final velocity, is equal to V naught, which is the initial velocity, plus acceleration times time. So the units of velocity are meters per second, which is length over time. Now I want to emphasize at this point that both of these are velocities. The subscripts are just indicating a little bit about what kind of velocity it is. This equation describes motion. So if I throw this marker in the air, my initial velocity is going to be the velocity when it leaves my hand. The final velocity is when I catch it, assuming we're interested in the entire time that the thing is traveling. So these are both going to have units of meters per second. We also have an acceleration. The acceleration has units of meters over second squared, or length over time squared, and time has units of seconds or time. So now let's make sure every term works. So our first term is VF, and we've already done this. VF has units of meters per second. V naught also has units of meters per second, which this means that the only term left for us to figure out is A times T. So the units of A times the units of T, if we do that out, we have meters over second squared times seconds. Well, this second is going to cancel with one of the seconds on the bottom, and we get meters per second. And you can actually see the same effect if we use the more abstract general units. So acceleration has units of length over time squared times the unit of time for time, and this cancels with one of those, and you're left with length over time, which is the same as velocity. So all the units have this, all the terms have the same units. Remember, this is a term because it's separate from this. It's not being multiplied or divided by it or anything like that. So all the terms work. Let's do one more. And I'm going to, again, use a kinematic equation. Let's use x is equal to v naught plus vf divided by 2 times time. Now, this looks slightly different because it's not really clear what the terms are here, and we have a number, which we haven't had before. But it turns out this is also very straightforward if you just apply the process we've been using. So the units of x, which is the position, is going to be meters or length. The units of velocity are meters per second, or length divided by time. And the units of time are seconds, or time. So here, we actually, to simplify this out, it's easier if we just distribute the t, and then we can look at each term. So this equation, distributing the t, we get v naught times t divided by 2 plus vf times t divided by 2. So let's look at the units of each of these terms. We know that the units of x is length or meters. So that means these should also have units of length or meters. So let's look at the units of, I'll switch colors again. Let's look at the units of v naught times the units of t divided by the units of 2. And this is the same thing as this, because we could just switch this 0 with an f, and then we have the same thing. So here, the first thing we're going to do is what are the units of 2? A number, just a mathematical given floating magical number, has no units. So this we can ignore altogether. And we're left with v naught and t. So the units of v naught are meters per second, and the units of time are seconds. And the seconds cancel, we're left with meters, it matches this, and this is going to have the same thing. And if we do it with length and time, the more abstract units, then we're going to get that velocity has units of length over time, multiplied by t, which has units of time, and the time units cancel, we're left with the length unit, which is what we want for x. And that is how you generally check if units make sense. Anytime asking if units make sense, this is the process you're going to do. You're going to look at the equation, you're going to have the units in front of you, and in blue, this is the work that you need to show, this is the work that you need to do when doing this problem. You can also set it up where you have, you can actually set up the equation and say, instead let's say the units of x are equal to the units of v naught plus the units of vf divided by the units of 2, all times the units of t. And then you can make substitutions. And you can say, well, the units of x are meters, or length. And this is equal to, well, the units of velocity are meters per second. 2 has no units, so that goes away. Here we say the units of velocity are length over time. And then we're adding to it, well, this is units of meters per second. And it's all being multiplied by seconds. So we have plus L over t, all being multiplied by t. And remember that when you have multiplication, that's multiplying something, a set of terms inside the parentheses, you distribute it. So this is multiplying both of these. This is multiplying both of these. So those all cancel, and you're left with meters plus meters, and length plus length. Now there's some confusion because this doesn't make sense. M equals m plus m. M plus m is 2m. 2m can't equal m. That doesn't make a whole lot of sense. Well, recall that these aren't actually variables. They're just units. Is it possible to get units of length, which is meters, when you add two lengths together? Yes, of course it is. This is just confirming that, yeah, a sum of two lengths is going to be a length. So that's why this works. And using the other type of analysis I did, where you just look at the terms, avoids any of the confusion from trying to manipulate the equations. So hopefully that's helpful. And that's how you check if units make sense.